Ryōiki Tenkai. The domain and range of a quadratic function. Here, we have a representative quadratic function where there is no middle coefficient or b coefficient. You have here x squared and then minus 4. We don't have the x term. So let's try to determine the domain and range of this given quadratic function where b is not around. We can rewrite this function in terms of y. Our function of x or f of x can be represented by y. So we have here y is equal to our right hand side x squared minus 4. The domain of this function is a set of all possible values of x that can be substituted here that will give us a real value result for our y. In short, we need to look for the values of x that will make this entire expression real. As you can see, we can substitute any value of x here. If we are going to substitute positive integer 1 squared is 1 minus 4, that's negative 3. If we're going to substitute here 0 squared is 0 minus 4, we have still a real number. If we are going to substitute fraction, let's say 1/2, the square of 1/2 is 1/4. 1/4 minus 4 is we have negative 15 fourths. It's still a real number. Even if it's square root of 2, an irrational number, the square of square root of 2 is 2 minus 4, negative 4, still a real number. If we have a quadratic function just like this, the set or the domain is the set of all real numbers. In short, there are no restrictions as to the possible values of x. Because if we are going to substitute, as long as it's real number, we're talking about the real numbers here, if we are going to substitute any real number here, may it be integer, negative integer, fraction, irrational numbers, our value for y is still a real number. That's the hint that you can always remember if we talk about the domain of our quadratic function. In set builder notation, you can rewrite this set of x, because it's domain, set of x such that x is an element of a real number with no restrictions. Now let's look at the range of this quadratic function. The range now is a set of all possible values of y. Okay? Now, here comes the catch. If our domain has any restriction, that is easier for us to determine the possible restrictions as well for our range. But since there are no restrictions here for our domain because it includes all, there might also be analyses that we can do for quadratic function. And here's the thing. For the range of quadratic function, we are going to use here the concept of the vertex. Okay? The vertex of this quadratic function. Let me rewrite here y is equal to x squared minus 4. The vertex of the graph of a quadratic function will tell us the portion of our graph where it changes its direction. May it be from left to right going up, and then when you reach that vertex, it will change down, or vice versa, going down, and it will change at the specific point, that's the vertex, it will go up. We also have here the point later to illustrate it on our Cartesian plane. But to determine the vertex of this quadratic function, we're going to use this formula. The vertex is equal to, you have here negative b over 2a, and you have here 4ac minus b squared over 4a. Once we determine the vertex, take a look at this value here. This is the y value of our vertex. That is actually the value that we are going to refer on, including a little bit analysis. So where do we get this a, b, and c? The a coefficient is the coefficient of x squared. That's 1x squared, so that's 1. The b coefficient is the coefficient of our middle term or the x term. Since we don't have x term here, that's 0. And our c is the constant which is negative 4. Now, of course, you have this formula to determine the y coordinate of your y value of your vertex. But we could also start by getting here this one here. So that's the value of x, negative b over 2a. So you have negative 0 over 2 times 1. No matter what is the result of that, your x is 0. This is the value for the coordinate of your x coordinate of your vertex. Now, using this, you don't actually need to memorize this formula. Simply substitute this value of x on our given function or equation in this case. So 0 squared, that's 0. So the value of your y is negative 4. In short, the vertex is at 0 and negative 4. Okay. Once you will get this, as mentioned earlier, this is our what do you call this one? This is our value of our y, and we can now determine the range. The range here is a set of all y such that y, and you have here minus 4. But what notation now? Greater than or equal? Equal, less than? What the determination for this is your a coefficient here. If your a coefficient is positive, as given here, your graph is opening upwards. And if it's opening upwards, automatically you'll be using here greater than or equal. This is the strategy in solving for the range of our quadratic function. Okay, the domain is as easy as it is because it's a set of real numbers, but for our range, we'll be using the vertex. Let me illustrate that as a graph. And in this graph, of course, our x-axis is the horizontal axis here. Our vertical axis is our y. Let us try to plot the graph of this function and see if our domain and range are both correct, just by analysis. Okay? As mentioned, the range, for our range, we take here the y value of our vertex, and the sign here will be determined on the sign of our a, which is positive, so it should be greater than or equal. If it's negative, it's the other way around. Let's point here the vertex. It's at 0 and negative 4. 1, 2, 3, 4. This is our vertex at 0 and negative 4. Once we had that, let's pick x values. Because your graph for quadratic function is a parabola, you actually need at least 5 points to determine the movement of our graph. So we need here the value of x here and here as well, x here and here as well. So if x is equal to negative 2, substitute it in our function or our equation here. We have negative 2 squared is 4 minus 4. Your y is 0. If x is equal to negative 1, you have negative 1 squared is 1 minus 4, so y is negative 3. On the other way around, if x is equal to 1, substitute 1 here, 1 squared minus 4, y is also negative 3. And finally, if x is 2, 2 squared is 4, 4 minus 4, you have here 0. These are the other 4 points that you can plot here. What we have here, negative 2 and 0. We have negative 1 and negative 3. 1 and negative 3. We have 2 and 0. So if my graph is accurate, just for the purpose of this discussion, okay, for a while, this is how our graph will look like. More or less like this. Okay? Sorry. It's a parabolic graph like this one here. It's not a V, because if you're going to include fractions here, this will not be straight. This is a little bit curvy. So when you look at this graph, okay, take note that it opens upward. As I mentioned earlier, the vertex is the point of inflection or where your graph changes direction from it goes down. Once it reaches that vertex, it goes up. Now let's look at the horizontal movement for our range. This is the checking. Earlier, we mentioned, that's domain. Earlier, we mentioned that our domain is a set of real numbers. If we're going to look at the movement here, if we have here -3, -4, -5, moving here until positive infinity, your graph will still continue going upward, and this will still continue going upward with no restriction. So when you look at the horizontal movement, there are no restriction, hence our domain for a set of real numbers is correct. Now, how about our range? Take that our range is the movement from top to bottom, or up and down. As you look at the graph, this is the least possible value of y. We don't have values here that are included in our graph. The value of y ends here. This is the smallest. Hence, our range of having -4 as our endpoint is correct. And we look at it as this graph will be using other values of x here and x here as well. It will just continue going up here. In short, take note that the values of x do not actually end on both sides. In short, this y here will also increase without bound. That's why our sign here is greater than. And why do we use equal as mentioned? Because we included that point there. That's the value of our y. This is the illustration why our answers for our domain and range for this given quadratic function is now correct. For the next functions, please do not forget to like this video, share this, comment down, and subscribe to our channel. This is for us to expand our domain further.